Hello students, welcome to our channel of Parallax Tutorial. My name is Pallabi and today we are going to continue with the second video on the series of topic-wise past paper questions of IBAAHL Mathematics Paper 1. This is a no calculator paper and the topic we are currently doing is functions. In today's video, we are going to cover the subpart C of question number 2 from our first video. Please click on the link given in the description box to access the previous video. In this video, I have used integration by parts to solve this question and given a detailed explanation on it. Please pause the video and note down the steps if required from time to time. We stopped at this question. You can just click on the link given in the description for the previous video so that you find the question. However, let me just, this was the question basically which we were solving in the previous video. And therefore, our f of x is given as e to the power minus x cos x. And we sketched the graph of f. How we did that is given in the previous video. The graph came out to be like this. So it started from here when it was 0, then it went like this, and it stopped over here till 3 pi by 2. Again, please check out the link given in the description below to access the previous video. So this is pi by 2, this is 3 pi by 2. The question was, now let's come back to the question which we are supposed to solve today. It's a 7 marker, so it's going to be a long question. So please take down notes as you do this, right? We are supposed to find the ratio of area A, which is this, A, to the ratio of area B. We have to find A by B. Now, integration has to be used over here. Remember, the IB questions will never be on one particular topic. I'm sure you all are already aware of that, which means it will be a combination of topics, and difficult questions are usually combination questions. For example, this question, although it is part of the functions topic, however, it includes a big chunk of integration or calculus. So when we do integration in our videos, we will come across this method which we are going to use now. However, since the question is from functions, I would just like to solve this. You can take down the notes and do each and every step along with me. That would help you. So basically, we are finding these two areas and their ratios. Remember, we have to find the areas individually. That is, we have to find the area A first, area B later, and then divide both. The function for both is same, which is e to the power minus x cos x. The rule which we are going to use over here is called integration by parts, where you have two functions, u and v dash. V dash over here means differentiation of the second function, which is v, is equal to uv minus integral of v u dash. Again, u dash becomes the differentiation of the first function. So that's the rule which we are going to use. And how do we integrate it? So basically our region A and region B will be both same integral, which is e to the power minus x cos x, because after all the function is same. Remember, the function is still the same function which we were doing in the previous video, this white line. This is the function. However, the limits vary. For region A, the limits will be from 0 to pi by 2. For region B, the limits will be pi by 2 to 3 pi by 2, but the integral will remain same. Okay, so all we need to do is just figure out what the integral is, then apply limits and get the area, right? Okay, let's begin with the integral. So I'll not put limits right now. Let's first integrate it. So e to the power minus x cos x. If you look at the formula which we are using, which is integration by parts, over here our u is, let's write down the values, what we take as u, v, u dash, and v dash, so that we don't have any difficulty here. So u is e to the power minus x. V dash will be cos of x, which means v will be what is integration of cos x, right? So our v would be sine x. And u dash would be e to the power minus x, which is just differentiation of e to the power minus x. And you put a negative sign before it because you are using chain rule over here where the negative x is also differentiated and it becomes minus 1. Okay. Again, all of this will be covered when we do our calculus topic. Okay, after we have noted down u, v, u dash, and v dash, now we just simply apply the formula, right? So u, as you see, u is e to the power minus x, correct? And v dash, which is cos x, correct? So should be equal to u into v minus v u dash. Let's write it down. Integral e to the power minus x cos x would be equal to u, which is e to the power minus x, into v, which is sine x, minus integral of v, which is sine x again. This is integral of v, which is sine x, and multiplied by u dash, which is minus e to the power minus x. I hope this is clear. Let's take this as e. Let's write I. Let's write this down as I. Okay, e to the power minus x cos x. Integral of that is taken to be I. This is I. So I is equal to e to the power minus x sine x. This minus and minus cancel out. You put a plus integration of e to the power minus x sine x. Correct? Now again, we have to apply the integration by parts in this integral. Okay, let's do that again. So I'm going to write it over here so that we know what we are doing. So basically, e to the power minus x sine x, and we are supposed to integrate it. We are taking it as, so again, now this time what will be the u, v, u dash, and v dash? Let's write that down again. So our u will be e to the power minus x. This is our u. Our v dash will be sine x. Our v, therefore, will be minus cos x, and u dash will be minus e to the power minus x. Let's put these down into the formula. So integral of u, v dash will be u into v, which is e to the power minus x into minus cos x. I've just put the minus over here, which is our u into v, minus integral of v u dash. What was our v? It's minus cos x again. And u dash is minus e to the power minus x. So we have minus e to the power minus x cos x. The minus and minus over here can get cancelled. You have a minus integral of e to the power minus x cos x. And don't forget to put a dx every time. Put a dx every time whenever you're writing the integral. Over here also it's dx, and over here also it's dx, dx. Okay, right. Now, so if you have a look over here, this is again nothing but your I. Remember, this was I. So I, and this is just minus e to the power minus x cos x minus I. Putting it back over here, that is putting the value of e to the power minus x sine x dx, which we calculated from here, right, which we got as this, back into the equation, we get I is equal to e to the power minus x sine x minus e to the power minus x cos x minus, so it will be a minus I, right? Let's put the i's together. What do we get? So if you put the i's together and solving for I, that is making I the subject, we get 2I is equal to e to the power minus x common outside. We are left with sine x minus cos x And therefore, I will be e to the power minus x by 2 sine x minus cos x. Now, take a break over here, absorb what we have done till now. We have solved the main integral. Now, all we have to do is apply the limits and see what we get as the area, right? For both the sections A. Now, we have to just apply limits into this formula which we have got and see what we get as the two areas, then divide the ratios, right? This was the main integration which we have done. I'm going to erase this part so that now, since we already have the integral, we can start calculating the area. We'll do it individually and later we will combine and see whether we get the answer or not. So let's begin. And also we don't need this because we've already got the value of the integral, so we can get this part erased as well, right? And we have our value of I over here. Let's write it down over here. I'll use a different color so that we know that this is the integral which we are talking about. It is sine x minus cos x. Now, for part A, this part, right? A, our limits have to be e to the power minus x by 2 sine x minus cos x all the way from 0 to pi by 2. Now, how do we apply definite integrals and limits to them? We can erase this part as well. Right. So what do? We put down the limits the way it is. Let's put down pi by 2 first. So e to the power minus pi by 2. There's a 2 here. We are left with sine pi by 2 minus cos pi by 2. Okay, that's 1. Minus e to the power is just 0 by 2. And we get sine 0 minus cos 0. What does this give us? E to the power minus pi by 2 sine pi by 2 is just 1. Cos pi by 2 is 0. Sine 0 is 0. Minus cos 0 is just minus 1. You add it to this, you get plus. E to the power 0 is just 1. So it's just plus 1 by 2. And that's it. So it's basically 1 by 2 times e to the power minus pi by 2 plus 1. This is the area for region A after we apply the definite integrals. Now, one thing over here is when we have solved the integral, you always need to add a c to it. So there is a c which is added, but since we have both the areas and it's a definite integral, in indefinite integral, we add a c. Indefinite integral, once you apply the limits, you don't put a separate constant, right? Okay, that was for region A. Let's do the same thing for region B and see what we get. So for region B now, all you need to do is you use the same formula, which is here I was e to the power minus x by 2 sine x minus cos x, and the whole thing is from pi by 2 this time to 3 pi by 2. How did I get that? If you look at the region B, have a look at region B over here. It is between pi by 2 and 3 pi by 2. Now, remember, the area which we are going to get here will come out as negative because it's below the x-axis. However, if we have to find the ratio, the area we usually take as positive. So that is something which we have to keep in mind. Let's see whether that happens or not. So this is our B, e to the power minus x. Okay, so now let's apply the limits. Let me write this properly. So we have basically pi by 2 to 3 pi by 2. And let's solve. So we have e to the power minus 3 pi by 2 sine 3 pi by 2 minus cos 3 pi by 2. The whole thing then minus e to the power minus pi by 2, applying the lower limit by 2 sine pi by 2 minus cos pi by 2. Let's see what all becomes 0. This is 0. 3 pi by 2 is 0. Cos of pi by 2 is 0. So in case you're wondering why this is 0, let's just have a look at it. See, this is the quadrant 0, pi by 2, 3 pi by 2. Sorry, not 3 pi by 2. That's pi. That's pi. It's a long question. Maybe that's why this is happening. And this is 3 pi by 2, right? So when we move like this, that was the domain given for the function as well. So what happens over here is at pi by 2, the cos value becomes 0. Okay. Similarly, for 3 pi by 2, also the cos value will be 0. Sine of pi by 2 will be plus 1. Sine of 3 pi by 2 will be minus 1. Cos, that's it. That's all we need to know. Okay. Rest of the things we'll do when we do trigonometry. Okay, moving on. So sine of 3 pi by 2, let's put in the values now. So this is e to the power minus 3 pi by 2 by 2. And sine of 3 pi by 2 is just coming out to be minus 1. Okay, then we have minus e to the power minus pi by 2 by 2. Sine of pi by 2 is just 1, right? So what did we get the B area as? Finally, we got e to the power. Let's see whether I have got the same area in my calculations as well, so that there's no mistake since it's a long question. More or less, it should be same. Let's see. E to the power minus 3 pi by 2 by 2 minus of that minus e to the power minus pi by 2 by 2. That's our B. Now what do we do? Question is we have to find the ratio of A is to B, right? So I can again, so please take some time to note this down, or you can just note it down, or you can just revise what we have done. I'll give you 30 seconds, maybe 10 seconds to do that. And then I'm going to erase part of the board. 1, 2, 3, 4, 5. Let's go. So now we move on to calculate the ratio, the last part of the question, right? Okay, so we have A and we have B already given to us. All we need to do is find the ratio of the areas. We don't need this now. We have already solved it. And we also don't need this, right? B is also done. So we have A and B, and all we need to do is just divide A with B. Let's use this part of the board. A by B would be, see, half is common in both, so I can just take half outside. A is e to the power minus pi by 2 plus 1. And B is half outside, minus half outside. Actually, I'm left with e to the power minus 3 pi by 2 plus e to the power minus pi by 2. Now I can cancel out my halves, right? As we see, B is coming out to be negative, which is what we predicted as well. Okay, now the question, let's have a look at what we have to figure out, right? It has to be e to the power pi by 2 plus 1, not minus pi by 2 plus 1. And it should be e to the power pi plus 1. So what you do over here is, now you divide the whole thing, all the terms, by e to the power minus 3 pi by 2. The reason I'm doing this, now you'll wonder why all of a sudden we are doing this step, right? See, what I'm thinking is I want to get my denominator as e to the power pi plus 1, which means if I just divide the whole thing, this numerator and denominator, with e to the power minus 3 pi by 2, in my mind, this becomes 1, and this divided by, imagine, 3 e to the power minus 3 pi by 2. When this goes on top, you can use the indices rules, right? So it will be 3 pi by 2 minus pi by 2, which is, I hope you're getting this. So it's e to the power 3 pi by 2 minus pi by 2, which is e to the power 2 pi by 2. So you get e to the power pi, which is what I want, e to the power pi plus 1. That's what I want in the denominator. I'm not thinking about the numerator at all, okay, right now, because I'm just going one step at a time. So I take e to the power minus 3 pi by 2 common, and I divide the whole thing with it, which means the top also gets divided by the same number. So this becomes e to the power minus 3 pi by 2 plus 1 by e to the power minus 3 pi by 2 whole thing. This becomes 1 plus e to the power minus pi by 2 minus 3 pi plus 3 pi by 2, so which is 2 pi by 2, which is pi. I hope this made sense till here. Okay. So now we can erase the A and B's. We don't need them anymore. We have already used them in our question. Okay, next step. So A by B will be what? Let's see. So e to the power minus pi by 2 plus 3 pi by 2. What do we get? E to the power minus pi by 2 plus 3 pi by 2 will be e to the power pi. Plus e to the power, this will switch up. We'll get a 3 pi by 2. Bottom will be 1 plus e to the power pi. Okay, we've already got our denominator. Now we need our numerator. Numerator is what? E to the power pi has to be outside. So we remove the e to the power pi. The reason I'm doing this is because this is what we have to prove. So e to the power pi comes out. What am I left with? 1 plus. So when e to the power pi goes out, this gets divided by e to the power pi, which means this is what happens to it, right? So 3 pi by 2 minus pi means 3 pi by 2 minus pi by 2, which is 2 pi by 2, or 3 to the power pi by 2 minus pi, which will be 3 pi minus 2 pi by 2, which is pi by 2, right? So you'll get e to the power pi by 2. And the whole thing is 1 plus e to the power pi. Where did the negative go? Oh, there is a negative over here, okay? In the bottom, negative, negative. However, you don't consider the negative again because this is basically the negative sign is due to the area coming under the x-axis. So in questions, when you have to actually add areas A and B, all you do is you switch the sign. Okay, so this will be considered positive, and you can consider it positive since it's an area. It can never be negative. So this is what you got, and hence proved. Ta-da! So this is 3e to the power. Let's just check whether we have done this correctly. Yeah, and this gives you your 7 marks. So this is a detailed solution of this particular question. Any step you don't find, I mean, go through all the steps, see. So first thing, I'll very quickly revise what we did. So we first talked about the formula which we have to use over here, integration by parts. I'll be discussing this later on when we take up calculus, right, in detail. And then how to apply the area formula under an integral, which is just integrating, right? That's how. And then again, dividing the function into 2 limits, right? One region becomes A, one region becomes B. Then we found out the integral first using the integration by parts. We found out region A, definite integral, found out region B, divided both, took some things common, used the powers and indices formulas, and finally we got this result which we wanted, and we get our 7 marks. I hope this made some sense, and I hope you understood what I did over here. That's all for today. And please don't forget to like and subscribe my videos. Thank you.